All right, 2.2 notes. We're going to be graphing functions, graphing piecewise functions. All right, so our piecewise function has two parts to it, so we're going to graph each one of them separately. So when graphing, what does an x squared graph look like? A parabola, thank you. Like a U. So we know that it has this U shape. So we're going to plug in points to see where exactly our U shape is. We always want to start by plugging in the number that it gives us. So here I'm going to start by plugging in 1. So notice how it said x is less than or equal to 1. That 1 is going to be our starting point. So I'm going to start by plugging in 1. So I'm going to plug in values for x, get values for y, and that's going to be our point xy. So I'm plugging it into this piece. I'm just working with the first piece. So we have 1 squared. What's 1 squared? 1. So my first point's 1, 1. And just like how when we graphed things on a number line, if we have greater than or equal to or less than or equal to, we put a closed circle at that point. Bless you. If we have greater than or less than, it's an open circle at that point. So at 1, is it going to be an open or closed circle? Closed circle because it's less than or equal to. So I'm going to go to the right one and up 1 and put a closed circle. Now when we have parabolas, we usually want to plug in a couple points just so we can see where exactly our parabola is going. So the next point we want to plug in has to be something that satisfies this. So what's a number that's less than 1? 0. So we have 0 squared. What's 0 squared? 0. So our next point that we're going to plug in is 0, 0. Again, we still can't really see what our parabola is doing, so let's plug in another number. What's another number less than 1? Negative 1. So we have negative 1 squared, and what's negative 1 squared? 1. So our point would be negative 1, 1. So on our graph, we're going to go to the left 1 and up 1. Now with 3 points, can we see kind of what our parabola is going to do? Yes. We always start at the point that's given, so this is our starting point. It's like connect the dots. We start at the number that's given and then go through the other ones. So we only have an arrow on one side of our parabola. That's because we had to start at our point 1, 1. So that is our first piece. Any questions there? We're going to do the same thing with the second piece. However, we have 2x plus 1. What shape do you think this graph is going to have? Why a line? Because there's only one x. It kind of looks like y equals mx plus b, right? Which is the shape of a line. So with a line, we only need 2 points to plug in because you can connect your 2 points with a straight line. So what's the first point that we should plug in? 1. Awesome. Always plug in the one that it gives you. So let's start by plugging in 1. So we have 2 times 1 plus 1. So 2 plus 1 would be 3. So our point's going to be 1, 3. At this point, do I have an open or closed circle? Open circle. Awesome, because it's just greater than. So I'm going to go to the right 1 and up 3 and put an open circle. Now I need to plug in another point to tell which direction my line's going to go. So what's a number that's greater than 1? 2. So let's plug in 2. So we have 2 times 2 plus 1, which would be 4 plus 1, which is 5. So 2, 5. Now, when we plug in our second point or third point, that just tells us the direction of our graph, so we don't also put an open circle at that point. So that just tells us the direction. So our next point, we're going to go to the right 2 and up 5 and just put a little dot because that tells us the direction. So we start at the first number, start at the number that was given, and we go through the direction of the second point that we got. So this is our piecewise graph. All right, let's look at the next one. For the next one, we have 3 pieces, but we do the same thing. So let's start with our first piece. So I have negative 4x plus 3. What's the shape of this graph going to be? A line. Awesome. Again, because it looks like y equals mx plus b. So it's going to be a line. And with a line, we only need to plug in 2 points. So I'm going to draw my graph here, my little table to help us plug things in. What's the first number I'm going to plug into x? Negative 1, because that's the number that's given. So negative 1. So we have negative 4 times negative 1 plus 3, which would be positive 4 plus 3, which is 7. So my first point is negative 1, comma 7. At this point, do I have an open or closed circle? Open. Awesome, because it is a less than sign. So we're going to go on our graph. We go to the left to negative 1 and up 7. And put an open circle there. Next, we wanted to plug in a number that is less than negative 1. So what's a number less than negative 1? Negative 2. So we have negative 4 times negative 2 plus 3 would be 8 plus 3, which is 11. So my next point's negative 2, comma 11. Now this second point just tells us the direction, so it's not also an open circle. It's just a normal point. So I go to the left to negative 2 and up 11. It's a little bit off of our graph, but it'd be right there. Once we have 2 points for our line, we can connect the dots. We start at the open circle and go through the second point. So this is our first piece. All right, let's do the second part now. What shape of our graph is 1/2 x minus 1 going to have? A line. So it's going to be a line again. Now, because we have 3 pieces of our piecewise function, the middle one is going to tell us where we need to start and stop. So these are going to be the 2 key points that I plug in. So you have to plug in negative 1 and you have to plug in 3. So I'm going to draw my table again. So what's the first number I want to plug in here? Negative 1. So I have 1/2 times negative 1 minus 1. This would be negative 1/2 minus 1. If it helps, you can leave it as a mixed number. This would be negative 1 and 1/2. So I have negative 1, comma, negative 1 and 1/2. At this point, do I have an open or closed circle? Open, because it's just a less than sign at negative 1. So I'm going to go to my graph. I go to the left to negative 1 and down negative 1/2. Negative 1 and 1/2. So that would be here. What number should I plug in next? 3. So I'm going to plug in the other number that it tells me to. So I have 1/2 times 3 minus 1, which would be 3/2 minus 1. What's 3/2 minus 1? 1/2. Perfect. So my next point's 3, comma 1/2. At this point, do I have an open or closed circle? Closed. So your middle piece, since it gives you 2 numbers to plug in, a starting and stopping, each of these points are going to have either an open or closed circle. It's got to be that defined point because it's a start and stop. So I'm going to go to the right 3 and up 1/2 and put a closed circle. So that would be our middle piece. Any questions there?
You don't put an arrow?
No, because it starts and stops. Because we have a start and a stop number.
Gotcha.
So if you have 3 pieces, the piece in the middle is not going to have an arrow because it'll give you a start and stop. Now let's look at our third piece. So 3 is just a number, just a constant. So here we're going to have a constant line. When you have a constant, it's just going to be a flat horizontal line. There's no slope to it, just a flat line. But if it helps, we can still plug in numbers. We're not really plugging them into anything, but just theoretically we can plug in numbers. What's the first number we are going to plug in into x? 3, because that's the number that's given. So I plug in 3. I don't have anything to plug into. What's my y always going to be? 3. So my first point is 3, 3. Do I have an open or closed circle at that point? Closed, because it's greater than or equal to. So let's go to our graph, bless you. We go to the right 3 and up 3. Bless you. Now the next point that we plug in is just going to be the direction that we go in. What's a number that's greater than 3? 4. Well, I'm not really plugging it in. What's our y always going to be here? 3. So my next point is 4, 3. Again, this doesn't get an open or closed circle. It just tells us the direction for our second point. So I'm going to go to the right 4 and up 3. And then connect my 2 dots. We start at the number that was given. These are starting points. So we start at that point, 3, 3, and go through the direction of 4, 3. So these would be the 3 pieces to our graph. All right, next we're going to talk about what makes something a function or not a function. There's ways to tell whether a graph is a function or not a function given a graph. So we can use this kind of to help us with our piecewise function. So if we're given a graph, we use the vertical line test to determine if it's a function or not. So let's say I'm going to give us 2 graphs here. Let's say I had one graph that was a circle. And then another one that was just a line. So with the vertical line test, you can take your pencil, because that's a vertical line, and hover it over the graph. If your graph touches the pencil in 2 spots, it fails the vertical line test, so it would be not a function. So with my circle here, if I hover my pencil, is the graph touching at 2 spots? Yeah, so this would fail the vertical line test, because if I put a vertical line here, it touches at 2 spots. So it fails, so this would be not a function. For our solid line, if I held my pencil over it in a vertical line, does it ever touch in 2 spots? No. So this would pass the vertical line test, so this is a function. So you can kind of use this to keep in mind with your piecewise functions. Your piecewise functions are going to be functions. They're not going to fail the vertical line test. Your graph won't touch in 2 points if you had a vertical line. So if you had a graph for your piecewise that looked like, let's say our 3 points went this way and this way, and I put a vertical line over it and it touched in 2 points, something went wrong with your graph. So you can always keep that in mind when doing your piecewise functions, because they're going to be functions. It's only going to touch in 1 point. We can also determine if something's a function algebraically. So when you have equations, y cannot be raised to an even power. So if we have something like y squared, this would be not a function. Or it can't be inside an absolute value. So if I had y inside an absolute value sign, this is also not a function. All right, so let's look at A. So we're just determining if it's a function. In A, is y squared? No, it doesn't have an even exponent. Is it in an absolute value sign? No. So do you think this is a function? Yes. Bless you. Yes, it's a function. What about for B? Why not? Y is squared, so this makes it not a function. What about for C? Yes. Y doesn't have an even exponent and it's not in the absolute value, so yes, this is a function. What about for D? Why not? Y is squared. And then what about for E? Why not? Because y is inside the absolute values, so this would be not a function. There are other rules that make things not a function. If we see them, I'm not sure how in depth we're going with this, but if we see them, I'll talk about them. But for now, these are the only ones that you need to know.